So the first class of the database, we discussed about the basic concepts about database, what is data, what is database, and what are the basic terminologies you should be familiar, and what are the job opportunities, what are the in real world perspective, what are the things that you need to know, those kind of stuff we discussed on the first class. And then we discussed some data models, different type of data models, and what is relational database. It is nothing but the table, right? So, and the basics of some SQL, and even we practiced how to connect to SQLite with the Jupyter notebook. So those are the stuff that we did in the first class. And the second class, we did a single table query. By using that DB browser of SQLite, we created a basic table, and we did some basic queries in single table, right? So we discussed some SQLite concepts and what are the commands, SQLite commands that you have to use to create table, what are the data types that is associated with SQLite, and what is the command to create database, drop database, what is the command to create table, drop table, and how to insert new data into table by using insert into command, and then how to retrieve the information from the table by using select from the table name command, and then how to order, or like how to retrieve the information in some certain ordered fashion, and then how to update the information, how to delete, all those stuff we discussed. Okay. In today's class, we are going to discuss how to perform query on multiple table. The real power of relational database is on querying on multiple table, because in real world, even if you take a very simple example of this class database, it will have a lot of content, right? Separate information about students, information about course, and the instructor related information, those kind of. So there are a lot of, you cannot just do the information retrieval in one single table. You have to work with multiple table. So the real power of relational database is on when we work with multiple tables together. So when we work with multiple tables together, we have to consider a lot of things. The first thing, imagine that you're just updating a row in one table. For example, you're adding a table in student. Okay. So if there is some other table that is associated with the student table, then the name, if you're changing the name of a student in that table, that information needs to be updated in the other table as well, right? Else there will be confusion, because when you're doing query on multiple table, if there is update on one table and that update is not reflected in other table, means that will create a lot of confusion. So we have to follow certain rule called normalization. It's called, there are three main rules are there, three normalization rules are there in SQL that we have to follow before we proceed with multiple table query. So the main thing is there should not be any redundancy, data redundancy. If there is one column in one table, there should not be the redundancy of that in other table. Okay. So there are certain rules that we have to follow as part of the normalization. I'm not going to go deeper into the normalization, because that will be too much, because we need to spend at least 2 classes if I have to go over this normalization. Anyway, you're going to learn it in your database management course, where you will learn these normalization concepts in detail. Okay. So, but the main thing that you have to understand in this normalization for this class is you have to avoid unnecessary duplication of data to protect this normalization rules. Okay. So that one thing you should keep it in your mind. Okay. So as part of this normalization, the key is an important feature in database. Okay. So key means unique value or entity. For example, if you take a student's table, then there should be one column that should be unique for each student. There may be 2 John in a class, right? There may be same first name, there may be same birthday. So there are a lot of columns that may have the redundancy in multiple rows. But one thing that should be unique for each row, that particular column which speaks about that particular row is called the primary key. For example, if you take student table, a student ID, that can be the primary key because two students cannot share the same ID. And if you take a table of person, then you can see that the SSN of a person, okay, SSN of a person, two person cannot share the same SSN. So SSN can be primary key. So the thing that you need to understand is primary key acts like a unique identifier for particular row, okay? So you have to decide which particular column, which particular information is going to be the primary key. So this primary key is important concept when it comes to multiple table queries. And there is another concept called foreign key. So foreign key, what is that? A table should have a primary key. It can have a foreign key. A foreign key is nothing but this foreign key should be the primary key in another table. For example, let's say that you have a table about a student what are the courses that the student is taking right now in the semester. They can have a column for holding all that information, like courses that he has enrolled. Okay, that course ID can be the foreign key for the student table. But if you create a separate table for course, the course ID will be the primary key for the course table. So the course ID, which is foreign key for student table, is going to be the primary key for the course table. So this is the concept about primary key and foreign key. So we have to maintain this primary key and foreign key concept to secure this normalization rules. Okay. So with this theoretical concept, let's move on to work with multiple tables. How to query on multiple tables. Let's move on to that concept. So when we work with multiple table, we will mainly use join command. Note down this command, join. So join operation link to different table, and we have to use the keyword called on. So where to join table, whether you want to join, because two table, if you're joining two tables, that should be a common column in both tables. So that based on that particular common column, we are going to join these two tables to retrieve some information. That's how it works. Okay. So multiple table queries. So the join on is the command that you'll be using when you join multiple tables together to perform query. Okay. So to create multiple query, to perform multiple query, first you have to have multiple table. So for this practice, I have created a database called book database. Okay, so bookstore database, we are going to create the database right now by using the DB browser. So be ready with the DB browser. You can do it along with me. So we are going to create a bookstore database, but this bookstore database is going to have two tables, classics table and the customer table. And then we are going to do some query on these two tables. And on the way, we are going to see like re-practice some of the other commands like alter command, those kind of stuff that we are going to practice. Okay, so let's start with that practice. First, let's create a database. So go to your DB browser for SQLite tool that I asked you to download. You have done it in your previous lab practice. So you should have this tool available. So go to that and create a new database, and you can click this button here. Click this new database and then give some name called book shop or book database, book DB, whatever. You can just give any name that you want. Automatically, the extension will be .db. So to avoid, I will just give book store. Okay, I have created the database. Now, I'm going to execute the query. So, okay, so I have created, you can just verify it where you have saved the database that I have created is saved here as book. Okay, just verify you have the table, the database that you have created. Now we are going to create table. Okay, so I have given the commands in the PPT slide. If you want, you can just refer it from the PPT slide. Okay, so the first command, we are going to create two tables. One table is called classics because it is going to have a classic book collection. So this is what we are going to create. Create table classics. So go click the execute SQL here. Okay, so create command table. So as I told you, always the keyword should be in uppercase. That is the thumb rule in SQL, but SQL is case insensitive language. But it's a thumb rule that always the keyword should be uppercase. So I have created a table called classics. And this table is going to have 4 columns, 4 fields. One column to save author information. SQLite can have 4 different data types: text, integer, blob, whole. Okay, there are 5 different data types. So this particular column, author name, is going to be in text. Title of the book is also going to be in text data type. And the type of the book is going to be in text data type, and the year is going to be the integer data type. So if you don't know this data type, we have covered this in the last class. What are the SQLite databases? So okay, already it seems like since I have executed it twice, let me open the database books. Did you create that data table? Okay. So next we are going to insert some rows to the table. Okay. So what are the rows that we are going to insert? So for that, it is really hard for you if you're going to type all those stuff in SQL, because there will be, you should be very conscious with the numbers, everything. So I will let you to copy the code from the PPT. If you want, you can copy it, because because when we do the query, there should not be any issue with the value. Okay, so we are going to add 5 rows to the classics table. So one with author Mark Twain, Jane Austen, Charles Darwin, Charles Dickens, and then Shakespeare. So with all these 5 authors, we are going to add this information to the classics table. Classics table. So you can just put these commands, insert into the classics table with author title type here, and the values of these columns are going to be these 5. Okay, so the first one is author, second one is title, and third one is the type of the book: fiction, non-fiction, okay, play, and then year. So if I execute it, why it's always what, you can just create a table name here like this, and then add field. You can just add fields like author. The author is going to be text. And if it is going to be the primary key, you can check it, but it is not primary key as of now. So, okay. And like that, let's add the another row. For the next author, for Jane Austen. So when you see execute without any errors, you are good to go. So I'm adding the third author by using insert into command. So I don't need to explain this command because we already practiced a lot of this insert into commands the last class. Okay, insert into classics table, and what are the columns and what are the values for that column. Then I'm adding the fourth row, where the author is Charles Dickens. And the last row with William Shakespeare. Okay, so now we have everything added. If you want to see how our table looks, you know the command. What command you have to use? Select star. Star means all the columns, and then from, and then classics. So you can see, you should be able to see this table. So when you do your lab practice or labs assignment or homework assignment, I need the screenshot, okay, with this code and the table. So that's what you're going to submit, because it's all about query. It's all about the commands that you're using. You cannot save it. There is a way to save it, but it is advanced concept. You cannot save this command. Do you understand? So it should be a screenshot. You have to take a screenshot of this query with this table, and then you have to submit this as your work, as like for both lab and homework, you have to submit this. So the next thing, we are going to add one more column. So just make sure that you have, if you're working on your lab, you can even take a screenshot right now. Okay, so you have created one table, that is classics table, but this table is not complete yet. We are going to add one more column. Okay, so that column is going to be the ISBN. Okay, so we're going to add ISBN as a column. So how to do that? So if you recall, we have one command called alter table command. Maybe let's create one more table for customer, and then let's come back and see how to add one more column to this classics table. So let's create another table. This table is to store customer information. Okay, so let's add table. How to create table. So I recommend you to type it, then only you'll be able to remember the commands. You should type it and you should see the errors, then only you'll understand how to code it without any errors. So create table customers. Customer is the table name. Column name is name, and the data type is text. And then ISBN, that is the ISBN of the thing that they have purchased. Okay, what they have purchased. So that is going to be the primary key here for the customer table. Okay, and we are executing this because what book they have purchased, the ISBN of the book. Okay. So now we have created customer table. Now we are going to add data. For this, I recommend you to copy and paste. Definitely you need to copy and paste because this ISBN number, you know, this number, if you have anything you missed, the number is wrong, then when you do the query will not work. So I recommend you to copy and paste because of this ISBN number. So we're going to use the insert into command to add the data into the customer table. Insert into customers, two column names, and we are adding the customer. This has only two columns. This customer table has only two columns, the name of the customer and the ISBN of the book that they have purchased. So when you execute, it goes without any error. So we have created two tables so far. Now we want to add one more column to the customer table, right? For that, we're going to use the alter classics table. Okay. So how this alter table command will work? You have to give this keyword alter table, and the table name, and add is the column. Okay, add ISBN and integer. So this is the command that we are going to work. So if you have any, when you do your homework, if you need to alter your table, then you should be familiar with this command. Alter table, the classic, the table name, and if you want to add, it should be add. If you want to modify, then it should be modify. Okay, so be familiar with these commands. We are going to add one more column to the classics table. Should work. I don't know. So sometimes you need to type it. Sometimes copying and pasting causes some error. But for this row, I really want you to copy and paste, because as I told you, how we are going to add, we are going to find out the book of the ISBN of the book by its year. That means if you look at the table, we are going to get the year. So which year, that year book, we are going to add the ISBN. So we are going to add the ISBN by using the update command, update set command. If you recall, we have done it in last class. To add some information in the table, you will use update set command. So what we are going to do, we are going to update the classics table, and we are going to set the ISBN, which we have added, a new column that we have added by this command. For that, we are going to set the values in the row. How we are going to set? To which row each ISBN belong? That we are going to set by the var class. Where the year is 1876, this is the ISBN of the book. Where the year of the book is 1811, then the ISBN is this. So with this, keeping it as a reference, we are updating the table. Okay, for that we are using update table. Update table. So update classic table, set ISBN column where year is this. So we are adding this new column to the classics table. So if you want to check how our current classic table looks, you can just, what command you have to use. Select star from classics. Now you can see the ISBN is added. You have to take a screenshot of this table. This is what proof that you have created your table. Okay, and then we have already, okay, maybe let's see how our customer table looks. So our customer table looks like this. So you can verify the classics table has also ISBN and the customer table also ISBN. So you can now guess that we are going to connect these tables. So we are going to do some query like, what is the author? What is the author of the book that Joe has purchased? What is the year of the book that Mary has purchased? What is the title of the book that Mary has purchased? So those kind of query, if we have that query, how to answer that query by joining this multiple table. For that, the only thing that connects these two tables are this ISBN. This ISBN is the primary key here for the customer table. That means it is a foreign key in the classics table. So these two key getting connected. Through that only we are making the we are trying to answer the query. Okay. So now what we are going to do, we are going to do some basic joining and doing some basic operation. For example, if you go to your slide, we are going to do query. If you want to get the customer information, so this is the query that we are going to work on. So if you want to get the customer information, who bought which books, we can do it by joining the table. How can we join it? So James got, what is the author and title of the book that Joe has purchased? What is the title and the author of the book that Mary has purchased? So that, how can we do that? If we find the ISBN of the book, then we can simply join these two tables and get this information. That's what we are going to do. So we are going to join these two tables. So there are multiple joins available. So first thing we are going to try is select. What are the things that we need? We need name of the customer, author of the book that he has purchased, title of the book that he has purchased. For that, where we can get this information? To get this information, we have to look on both tables, classics table and the customer table. So how can we work on both tables? For that, we have to use the join operation. So from customer, where that customer table is joined with classics, on where the ISBN column is there in both customers and classics. So here, this is how we are giving. The ISBN of the customer and the ISBN of the classic should match wherever it match, because there are only 3 customers. We have the tables with these customers. The 97800, 97805, 97805, 17. So those are the ISBN that we are going to look on, right? So this is how we are adding. So we can add this command, we can execute this command to get the answer for that query. Select name, author type from the customer, join classics on customer.isbn. Where we are joining, that's what we have to give with the on. ISBN of the customer, ISBN of the classics. Okay, we are adding it here. And if you execute it, that is something wrong here. Okay, let me type it. Customers dot ISBN should be equal to classics dot ISBN. If I execute this, it should work. So sometimes when you do copy and paste, if it shows any error, type it. Now we got the answer for the question. Which customer bought which book? We got the answer for this question. So please take screenshot of this result. This is what you're going to submit. So this is the answer for the first query. We're going to do multiple queries like that. So you have to submit the screenshot of the classics table. You have to submit the screenshot of the customer table, and you have to submit the screenshot of this query where you have the information of the author and title purchased by the customer. So you have to submit these 3 screenshots so far. The next thing, we're going to do multiple queries. One more query. We have just done it, right? Okay. So we did it with the join on class, right? So join on, there are multiple ways that you can perform query. If you don't want to use join on, there are another way that we can do this query. We can simply do that by using where class. Instead of join on, we can do the same query. We can answer the same query by using where class. So for that, select name, author, title from customers and classics. We can just give 2 names, and then we can give the where class, and then where it is joining ISBN. ISBN, it's where we are merging it, right? So we can just do the another query. We will get the same answer for this. Okay, select author, name, title from the customer and classics table, where this one ISBN should be same. So that is something wrong here. So let me change it and type it. From customer. You get the same query, same answer, right? So there are multiple ways you can do this query. Okay, try this as well. Take a screenshot with the where class. How can you get the same answer? Try this. And the second one, we are going to do the different types of joins. In any SQL based database, there are multiple, not only the SQL based, any database, you can perform multiple joining. There are multiple joining options available based on the query, based on the problem. Okay. So in SQLite, the basic types are SQLite inner join, SQLite outer join, and SQLite cross join. So these are the different types that we can perform based on the query. Okay. So what is SQLite inner join? Inner join is the most common type. It's a default type. It is used to combine all the rows from multiple tables where the join condition is satisfied. So it will just pick all rows. Note down the term. It will just pick the rows wherever the columns, the given column matches. It will just pick all the rows. So if that is the case that you want to do, then we can just go for inner join. It's a default type of join. And this is the syntax. Select command and from command, table 1 and table 2, you have to give inner join. By default, if you don't give, so for example, in the previous case, we gave join on right. So that is inner join by default, because even if you don't give the inner, it will be taken as inner because that is the default join option. Okay, let's try this. So let's try this on our customer and classics table, how we're going to join. So what we're going to do, we are going to get the customer information and the title information. Previously, we retrieved customer, author, and title. Now we want to retrieve the customer, title, and year of the book. How can we do that? Again, we need to depend on our primary key and secondary key, right? Based on only we can do the merging. So we are going to select author, title, and year from classic in a join with customer. Okay. So this is how we are going to do. And we have to give the on class, else it will not know how to match these two tables. You have to give the on class. Now, always primary and secondary keys will be the on class. So the command, select what are the columns from classics table and then doing inner join and the customer table. And then we are merging these two. For some reason, it requires us to type. So where classics table and ISBN table. So take a screenshot of this. So you can understand this on class is important where you're joining these two tables. And then you have to give the column names with the column that you're going to retrieve that with the table name. So these are the primary components. Whatever you see in uppercase or keywords. Okay, so that is an example for inner join. Let's do outer join. You want me to wait? So the next command that we are going to try is outer join. So in SQL, in most cases, in all kind of SQL-based databases, that outer join can be of 3 different types: light outer join, left outer join, right outer join, and full outer join. Okay. The SQLite supports only the left outer join. It cannot support the right and full outer join. But if you're using other databases, you can do the other outer joins as well. So let's try the outer join. It can be only left in SQLite. So what we are going to do this time, we're going to do the same thing, but instead of the customer, we are going to get the author of the book. Author of the book, customer table, and classics table. Why do we need to have the author is here, title is here? Author, title, customer. Let's try. But it is simply the author and title. We are not connecting the customer in this table. Let's do something else. Author, title. Okay. Author. Customer also. Customers also. From left to outer join from customer. Okay, let's do it. Select. Come on. What is the column name? Is it name? Yes, name, author. So no one has bought the Mark Twain author, and no one has bought William Shakespeare. So you can see it is null. So when you create a table, you have the options. If you might have noticed the create table option, you may have the option that if you don't want that particular column to be null, you can say not null. If you want a particular column to be primary key, you can say it is primary key. So there are a lot of options available. When you create table, you can do that. Okay, so this is the example of outer join. Okay, left outer join. You can see everything from the classic table has been retrieved. And only the customer table has only 3 rows. Okay, and the remaining things. So this is how the outer join work. So if you want the definition of the outer join, what is the outer join? Returns all the records from the left table and matched records from the right table. Do you see that? It retrieves all the record from the left table, that is classics table. And also it just gets the information from the customer table. Right table, it just gets which is matched, which is there. Okay. So this is called left outer join. Okay, left outer join. There is one more type of join called cross join, where cross join is kind of little bit complicated. It will like match every row of the first table will be matched with the every row of the second table. If the first table contains all the X columns, the second table also will get all the Y columns. So that means it will just display every information, every single bit of information in different repetition. Repetition will be that. That is the problem with the cross join. But this is how it works. It just displays everything as a separate row in the left column, left table, and then separately as right table. For example, if you don't know how it works, let's do this cross join on these 2 tables. Select star from classics, cross join customers. So we are doing cross joining on these 2 tables, cross and customer. So when we do that, you can see how it displays. Let me type it again. Classics. You can see we have only 5 rows in the classic table and 3 rows in the customer table. But you can see 5 into 3 cross multiplication. If you know the description, you might have seen the cross theory, right? So based on the cross theory, now it has 15 rows. 15 rows. Each will have the repetition. Okay. So this is how the cross join will work. It's not that popular one, particularly for querying. It's not that popular, but yeah. So that with the purpose, based on the purpose, you can just select a particular join tab. And the next thing that you're going to learn how to rename in case if the table name is so big, and if you do or anything table name or column name, if it is so big, then you can use the keyword called as keyword to change the name. You might have, this for in Python, when you import the library, you might have used that, right? So the similar thing in database, you can use the as keyword to change the name of the table. Instead of referring the full name, you can just give the nickname to the tables. Okay. So for example, here from customer as CUT, cust means instead of specifying the customers after this query, you can simply use CUST instead of specifying the full name. Okay. So this is how the as keyword, using as keyword to change the name of the table. So when you do the query itself, you can do, or you can just specify it separately. So what you're doing here, see, after you change the name to cust, then you can just specify cust.isbn and class.isbn instead of specifying customers.isbn and classes.isbn. You're just saying cust.isbn and class.isbn. Okay. So this is how the as keyword will work. So how to rename, give a nickname to a table by using as keyword. Okay, now, yes. So the next one, we are going to do multiple tables, joining multiple tables. Okay, already you might have created the student table. So in case if you were absent in the class and you don't have the student table, I will just add it from the first. I'm just going to create a new table. We are going to, so for this example, we just did it for 2 tables. Now we are going to work with 3 tables. Okay, let's work with 3 tables. Let's create a new database and let's give this name as student info. Student info database. Let's create a new database for these 3 tables. So this student info database has 3 tables, one for student, one for course, and one for member. Like how a particular course will have instructor and a student. Okay, what is the association of that particular person to that course? To save that member. So this particular database, we are going to have 3 tables. So first, let's create the student table. Student table, and let's add fields to that. So the name of the student, which is going to be the text. And then email of the student, that is also going to be text. And then ID of the student, that is going to be integer. And we are going to set that this ID should be not null. Okay, we are saying that if there is a record of a student, that record should have this column filled. There should not be any row without this column filled, not null. And primary key, that means this ID is going to be the primary key for that table. The particular column, ID column, is going to be the primary key. And then we are going to say auto increment. That means whenever you add new student, the ID will be incremented automatically 1 by 1. So if you have 4 students, you're adding 5th student, the ID will become 5. And it is going to be unique. That means no 2 students will have the same ID. So you can just use this GUI option to select, to give the details about that particular column. The data type can be selected here, whether not null or null, primary key, auto increment, and unique. All these 4 possibilities you can select when you create the table by using the GUI tool. But if you want to use the coding for that, then this is the code. Okay, the ID, or you have to specify integer, not null, unique, primary key, and auto increment. So if you have to, this is the equivalent coding for that. We have just done it without coding by using the GUI. So next we are going to create another table. Okay, so let's create another table, and this time let's create the table by using the query. We did it with the GUI last time. So the next table, the course table, we are going to create it by using the code. Create table course, and the ID, course ID is that is integer, not null, primary key, auto increment, unique. And title is going to be text, and that should be unique, but it is not a primary key. So this is our columns that a course table is going to have. Execute it, and it seems like there is some error. Let me type it. Okay, so title, and then that is the course table, and then we are going to create one more table, that is member table. The member table is going to connect these 2 tables, user ID, that is the member ID, and the course ID, and the role of the particular person in that course, whether an instructor or a student, that we are specifying as text, integer. That means we cannot say that student or instructor. We have to say we have to associate it with some number. It's optional, but still, how can we associate? We can say that 0 means student, 1 means instructor, like that. We can just associate it. That will come as part of the business rule. You will learn all these things in your database class. Okay, but right now we are just creating another table called member table. So this member table has 3 columns: user ID integer, course ID integer, role integer, which is 0 or 1, a student or instructor, and primary key, which is user ID and course ID. Here it has the 2 primary key. Okay, that is also possible. Okay, so we have created member table. Now we are going to add values to student table and course table and member table, so that we are going to try the queries. So let me add values first to the student table. I'm going to add data to the student table. Maybe you can just go to the PPT and you can just go to the first PPT where I have created insert into command. Okay, so it seems like that I don't have that information. Maybe you can randomly select some name. Let's say insert into student. I want you to do this query yourself so that you will understand. You type it. When you get errors, you will understand the code better. You can just give any name. John is the name. And John dot, let's say that John dot gsu dot edu is the email address. Okay. And ID, it is auto increment. We have given it as auto increment, but still you can assign if you want to assign. So the next student is going to be Colleen. CVL. Something. Okay. You can just give any name. It doesn't matter. But if you want to match the queries, then follow it. Ted, student name. And don't forget to change the student ID because that is our primary key. No primary key should not have the same value. That is the rule. Ted. And the fourth student that we are going to add is Sally. And the email ID is going to be anything. Okay, so we have added some, it doesn't need to be the same thing. You can just give any name, any email, but the ID should be unique. Okay, so I have inserted all these values to the student table. If you want to see whether we have inserted it without any issues, always give the select from command. So you can see the column that we have inserted. Now we are going to insert the courses, okay, that I have given in the slide. Insert Python, SQL, and PHP. Okay, so I'm just going to insert these rows into the course table. Okay, insert into course, and it has only one column. What is that column? Course ID will be automatically incremented, but we are just giving the title. Okay, so we have inserted the values for the course column, and then we are going to insert some value for the member column. So I have given those values, the user ID, course ID, and the association of that particular person to that course, whether instructor or student. We're just adding some columns, some rows to that. You can just copy and paste. So user ID 1 and the course ID. user ID and course ID, which course that is associated. You can see that we didn't give the course ID, but we have said that it should be auto increment. Okay, so automatically when you add new row, then the course ID, the first row will be 1, second row will be 2, second course will be 2, and third course will be 3, and fourth course will be 4. Like that, it will have the association. Now I'm just adding some values for the course member table with 3 columns. So I'm just adding line 5. One to 0. It's called constraint failed.